Hi everyone, today I'm going to show you some content on congruent triangles and how to determine if two triangles or a pair of triangles are in fact congruent. Then Miss Musolino will be going through a few examples with you. Let's start off by looking at the word congruent and what does it actually mean? Well, congruent means the same shape and size. Okay, so when we're looking at triangles, that obviously means the triangles are exactly the same shape and size. They're identical in every feature. Other figures can be congruent. So if we have two squares that are exactly the same size and shape, they're said to be congruent. Same goes with rectangles. They're the same shape and size. Again, they're said to be congruent. However, today we're going to be looking at triangles and looking at the 4 tests on how we can determine whether or not triangles are congruent. When you see the questions in your textbook, you'll be given you'll be given a pair of triangles, and generally you'll be given 3 pieces of information, and those 3 pieces of information determine which test proves that those triangles are congruent. So looking at our first pair of triangles, you can see there are 3 pairs of equal sides. This side is equal in length with this side, hence the 1 dash. This side is equal in length with this side, and the bottom edge of both our triangles are also equal. So side, side, and side are all equals, or SSS is the first proof for congruence. Moving on to the second test for congruence, you can see again we have a pair of triangles and 3 bits of information. Now here you can see that this length is equal to this length. Again, our bottom edges are equal length, and the included angle inside of those 2 given lengths is also equal. So the code I guess that we use here is SAS, for side, angle, side. Moving on to the third test for congruence. Okay, again we have 2 triangles, but here you can see, unlike the first 2 tests that I went through, these 2 triangles aren't sitting side by side in the same orientation as each other. You can see that one's been rotated from the other, but again, each triangle has 3 bits of information. In this case, we have an equal angle, a pair of equal angles, a second pair of equal angles, and a pair of lines which are the same length. So AAS means angle, angle, side. The fourth and final test for congruence, as you can see, involves a right angle triangle. Again, one's slightly flipped from the other, but again we have 3 bits of information. The first bit of information we're looking at is the right angle in the left-hand corner of our first triangle. Again, there's a right angle in the top right-hand corner of our second triangle. You can see also that the hypotenuse in both of these triangles is the same length, and so is another pair of sides in those triangles, giving us RHS for a right angle, a hypotenuse, and a side. So they're the 4 conditions or 4 proofs that we're going to use to compare pairs of triangles and to state whether or not they are in fact congruent.
So now that Mr. Markwick has shown us which tests we can use to prove congruence, we're going to look at a couple of examples. So the examples that we've come up with aren't in the exercise book. However, when we finish, if you would like to practice a little bit more, you can go to your exercise book and give it a bit more of a go. So here we have 2 triangles, and side by side we can see that they are exactly the same. So we have 3 ways of being able to identify whether these angles are in fact congruent. So we can first of all identify that the side AB is similar to is the same as side DE. So I'd write this as AB equals DE. And I might just change to a better texter. Okay. Secondly, we can see that both of these triangles have angles in the top corner. So what we can write here is angle A, B, C is equal to angle D, E, F. Now it's just important to remember that when we are writing out angles, the angle that we are identifying is always listed in the middle. So in this case, it's angle A, B, C, as B is the one we're trying to identify. You may, however, see people actually write this as just angle B equals angle E. So that's just another way of being able to identify that. Then thirdly, to test whether this triangle is congruent, we have a third side, and we can see that side BC is equal to side EF. So there we go. There's three ways of proving whether this angle is in fact congruent. We've looked at one side, an angle, and a side. So we would say that triangle, therefore, triangle ABC is congruent, we've got three lines, to triangle DEF, and we've proved this using the side angle side congruence test. Okay, and now we have a second example that we're going to go through. This one here might seem a little bit trickier because unlike our first example, where the two triangles were exactly the same side by side, in this example you can see that one of the triangles has been slightly rotated. However, when we look at them closely, we again have three pieces of information which match up. So we're going to start first of all by looking at the right angles, because we can see that there's a right angle in this triangle and also one in that one there. In this case, we would say that angle BAC is equal to angle EDF, with the reasoning that they are both 90-degree angles. Secondly, we can see that side AB is equal to side ED or DE. I'll say them in alphabetical order. AB equals DE. Then we move to our third piece of information. So across from our right angle, we have the longer side, which we identify as our hypotenuse. And in this triangle, BC is equal to the length of EF. So here we've identified that we have an angle, a side, and a hypotenuse that are all equal, proving that triangle ABC is congruent to triangle DEF. And if we think about which test we've used, well, we've got a right angle, a hypotenuse, and a side. So therefore, we have used the right angle, hypotenuse, side test to prove that these two triangles are congruent. So we hope that helps a little bit. Like we said, if you would like some more examples, make sure you refer to the exercise book. But thank you for watching. You can go to our YouTube page, click, comment, and subscribe. We'll see you next time.